All right, here we're looking at worksheet 3. First problem, we have a person running the pacer test in gym after they eat some Captain Crunch for breakfast. So our system here is the runner and the cereal. The initial situation is just after they finish breakfast, so that means they ate food, so they have some chemical energy. We're assuming they're not moving here, they're not like up in the air, there's no springs involved, so just chemical energy. And then at the end, we're saying they're running in the gym, so they have some kinetic energy from running, and then we left a little chemical energy in here, like maybe some of that Captain Crunch, they haven't used it all to run yet. So the chemical energy, you could really have 3 bars, 2 bars, 1 bar, 0 bars would also be fine. You just need to have chemical energy at the start, some kinetic energy at the end, and then however much leftover food you want to say. It doesn't specify. So 3 bars, 2 bars, 1 bar, any of that is fine for chemical energy, just as long as the end adds up to the beginning. So we have 1, 2, 3, 4 blocks here. So we have 3 plus 1, just 4 total blocks at the end. Our energy equation for this one is E chem equals EK plus a little bit of E chem left at the end. In the second situation, we have a ball rolling off the top of a table and it lands on the floor. So the initial situation is rolling on the table. So when it is rolling on the table, rolling means kinetic energy. On the table means it's up in the air, so it has some gravitational energy. No springs, no chemicals here. I forgot to say the ball is our system. Then at the end, it's about to hit the floor. So remember when we say that, that just means like all kinetic energy. It's like a millimeter above the ground. So we can basically round the EG down to 0. So we say that kinetic and gravitational energy it had at the start becomes all kinetic energy at the end. Notice once again, 1, 2, 3, 4 total blocks of energy, 2 plus 2, and we have 4 at the end. Our energy equation for this one, kinetic energy plus gravitational energy becomes just kinetic energy at the end. In the third one, the next set, they all kind of go together, but in the third one, we have a diver launching herself upwards off of a springboard before diving into the pool 5 meters below. So the initial situation here is moving on the board, and the final is the board kind of bent downwards. That's what displaced downwards means. So it's bent downwards and she's about to get launched up in the air. So at the start, moving on the board, she has kinetic energy and gravitational energy. Oh, once again, system, diver plus board. So at the beginning, kinetic energy plus gravitational energy, because she's moving on the board and the board is up above the surface of the water. Then, once the board springs downwards, so if it goes downwards, notice how we just put a little less EG here. So a little less than at the start. And that kinetic energy, she's like kind of jumped up, and now the diving board or the springboard is kind of compressed down, so it's ready to launch her up. So her kinetic energy and that little bit of gravitational energy just becomes spring energy here. So it gets stored in the board and it's ready to launch her up into the air. Our energy equation for this one, kinetic energy plus gravitational energy, just becomes gravitational energy and spring energy. So in here, number 4, this is where we said they kind of go together. So here, number 4, this time, same situation, but the initial position is the board displaced downwards. So that's the one we just drew here. So up above. So now, same situation that we just ended with. She's up in the air. The springboard is compressed and ready to launch her up. And then it says final at maximum height of jump. So that's when she's all the way up in the air. So we said at the end here, at her maximum height, it's all gravitational energy. This is assuming she jumps straight up. If she jumps out a little bit, maybe she's still moving at the top. She might have a little bit of EK here. That would also be fine. But just based on our interpretation, all EG. So that means she went straight up, and this is at her highest point, and she's like hanging in the air there for a second. So she stopped going up. She hasn't started to come back down yet. Our energy equation is just EG plus E spring equals EG at the end. This last one, same situation. We have the diver going off the springboard. The initial situation is the board displaced downwards, so these two should look exactly the same. And this time the final is about to hit the water. So after she went up in the air, now she's fallen back down. She's just about to hit the surface of the water. So this time, kind of like if we go back up top here with the ball about to hit the floor, she's about to hit the water now. So no EG or very small EG, so we can like round it down to 0. And it's just all EK. So our total energy that we had here has to be equal to our total energy, our total kinetic energy at the end. Our energy equation for this one is just EG plus E spring equals EK. Last one, we have a soccer ball rolling to a stop after it's kicked across a field. So the initial situation is it's already rolling, so after the kick, and then final situation, the ball has stopped. So here we have kinetic energy, not moving up in the air, no springs, no chemicals, nothing like that. So just kinetic energy. And then at the end, notice that we don't have kinetic energy anymore. We don't have gravitational, no spring or no chemical energy. So then we have to think like, where did it go? That's dissipated energy. So anytime something stops due to friction, that's where we say dissipated energy. And this will be important once we get into work. Just notice that our system for this one is the ball and the ground. If we don't say ground here, we can't have dissipated energy, and we have to include work, which is what you'll learn about next. Our energy equation for this one is EK, so kinetic energy just all gets dissipated, so EK equals E dis.